Ever feel like you're just swimming in information? Trying to find that one key idea that makes it all, well, click. It's not just about getting more data these days. The real challenge, the real power actually, is in understanding how knowledge itself gets built, like from the very beginning. So today we're doing a deep dive into something called the structure phase. It's part of this fascinating approach known as Taxshila technology.
hmm
Think of it like we're uncovering the blueprints, the actual architecture for how really advanced systems, complex models, and even how we understand things are put together. Our mission here really is to take you on that journey, that moment where abstract ideas, thoughts suddenly become real, tangible, functional things. And look, this isn't just for tech developers. It's like a blueprint for how you can think about learning, about building things, about innovating in your own world. We've got some surprising facts, some really practical insights lined up. So let's get into it. Okay, so let's really try to unpack this phase, the structure phase. What the material tells us is that it's this crucial second phase of technological development. Sometimes they just call it the architecture phase.
Right. And this is where things really start taking shape.
Exactly. It's described as the point where abstract modules of innovation begin to take organized and functional form.
Yeah, it's that moment, isn't it, where, like the sources say, creativity meets configuration. Your big ideas start getting locked into an actual structure.
So imagination turning into structured implementation, it's less about that first spark maybe, and more about laying down the solid tracks for it to run on.
And it's different from what you might think of as standard development. It's not just, ticking off product milestones. This phase is really about transforming those early concepts, those concept blueprints from the imagination and design phases into something much more defined.
Like knowledge architectures, embodied systems, and performance pathways. That sounds pretty serious.
It is. Think of it like going from a quick sketch to a full engineering drawing,
Well,
something you can actually build from.
okay, so who are the people actually doing this? The architects behind these blueprints. The sources mention a pretty interesting mix: core designers, small teachers, brainpage developers, and knowledge engineers. That doesn't sound like your standard dev team.
No, it's not. And what's fascinating here is that their job description goes way beyond just typical tech design. Their main task is to uh, synthesize the outputs from those earlier phases,
Mm.
pull it all together into these structured modules.
And while they're doing that,
They have to ensure it's personalized, that it can scale up, and that it's adaptable. Build that flexibility right in. The material calls them cognitive system builders. They're blending things like brainpage theory, modular design, and system scalability into every step.
so they're building systems meant to learn and grow, not just static things.
Exactly, that's the core idea.
And you mentioned modular design, modularity. That seems to be right at the heart of this structure phase.
Absolutely, it's fundamental.
The sources use that great analogy, building blocks, like Lego almost.
Yeah, it helps simplify really complex stuff, doesn't it? Makes it easier to grasp quickly. Rapid comprehension, as they put it. And it helps with knowledge transfer.
It makes you think, though, if modularity really is, like they say, the engine of scalable innovation,
Hmm.
how should we be thinking about breaking down any big problem? Not just tech, but education, maybe even personal goals.
That's a great question. And look at the benefits they list. For tech projects, it's scalability, efficiency, adaptability. Makes sense. Plus, it helps with reusability, maintainability, and system abstraction. Being able to swap parts out, fix things easily.
Right, avoids that nightmare where one tiny thing breaks and the whole system is useless.
Exactly. It allows different teams to work in parallel, gives you flexibility. It's presented as, yeah, the engine of scalable innovation.
Okay, now this next part. This really caught my eye, especially for anyone interested in how we actually learn. There's this unique Taxshila principle. Knowledge transfer is fundamentally motor-driven.
Ah, yes. That one's key.
It sort of challenges that whole idea of just sitting back and absorbing information passively, doesn't it?
It really does.
It suggests our brain literally must build learning pathways through physical and cognitive interaction with structured modules.
Right. It's an active process. You have to do something with the information.
So what does that mean for us? Like, what should we actually be doing to learn things properly, even outside this specific tech?
Well, this leads to the concept of the brain page, which is described as the visuomotor construction of knowledge.
Visuomotor. So seeing and doing.
Kind of. Imagine you're literally drawing connections in your mind as you interact, not just passively receiving, like building a mental model. And the research they mentioned is interesting. It found that pre-trained learners, they call them small teachers, people who already had a good base, they learned better.
Better how?
Higher retention, better application of the knowledge, faster mastery. When they worked within these structured modules, the structure helped them build those pathways more effectively.
And they even mention specific brain parts.
Yeah, the hippocampus and temporal lobes, they say these play a central role because they're involved in spatial memory, information organization, and sequence mapping.
So our brain is kind of mapping information spatially as we learn it through interaction?
That seems to be the idea, organizing it like a mental landscape.
Wow. Okay, so we've got brain science, modularity, but how do they make this practical? How do you actually build using these ideas? Are there tools, frameworks?
There are. The sources point to a few key ones they use in this phase.
Like what?
Well, first, the 7 KT dimensions, KT meaning knowledge transfer.
Okay.
And within those 7, 3 become really important here. Function matrix, module builder, and task formator.
Function matrix. What does that do?
It's about arranging the knowledge into meaningful patterns, sort of like creating that mental flowchart you mentioned earlier, organizing the what and how.
Right. Makes sense.
And what's fascinating is how these frameworks give you concrete steps for building. It's not just theory.
What's the other main one?
The other big one is SOTIM logic. Yeah, SOTIM. It stands for Space Object Time Instance Module.
Okay, that's a mouthful. What's its job?
Its purpose is to keep everything coherent and agile as you build. Maintain the integrity of the system. Think of it like maybe a really sophisticated blueprint or organizational system for knowledge. It tracks where information fits spatially, what it is, the object, when it happens, time, the specific version or occurrence, instance, and how it fits into a larger piece module.
So it ensures everything lines up correctly across all these different dimensions.
Precisely. It provides a reliable spatial temporal architecture for assembling modular systems. It helps optimize everything, from the physical layout to object interaction and task-specific execution. It's the guide for how all the pieces fit and work together.
That sounds incredibly detailed, very rigorous. But how do you get good at using these structures? How do you achieve mastery?
Well, they have something for that too. They talk about mastery loops.
Mastery loops?
Yeah. They're described as cycles of rehearsal, refinement, and reconfiguration of modular constructs.
So practice, basically, but structured practice.
Exactly. Deliberate practice built into the system. They're used to ensure lifelong learning and adaptive innovation. The whole point is to accelerate both individual and system-level expertise.
Like a continuous feedback loop for getting better faster.
Pretty much.
Yeah.
And supporting these loops, you have miniature schools.
Miniature schools. What are those?
They're described as core units, or test beds for structured modular execution.
Okay, so small learning groups.
Essentially, yes. Focused environments where you put the modular knowledge into practice right away.
Yeah.
They act as living laboratories. They encourage real-time feedback, peer-based correction, and autonomous task performance. It's where you actually solidify the skills. You learn by doing, together.
So, okay, pulling this all together.
Right.
What does it really mean for, for you listening, for your own learning, your own projects?
The implications are pretty significant, I think.
Well, first, there's that connection between the earlier phase, the definition phase, and the structure phase.
Right. They call it a symbiotic relationship.
Yeah. The definition phase provides the what and why, and then the structure phase adds the how.
Yeah, it creates that seamless transition from vision to reality. The blueprint starts getting built.
And beyond just building tech, there are these bigger ideas about learning itself.
Definitely. Like the argument that educational systems must shift from teaching to structuring. Meaning the focus should be on learning through construction, rehearsal, and structural interaction, not just, listening to lectures passively. More active engagement.
That's a big shift.
It is.
And then there's the idea that structured modularity enhances personalization and equity. How does that work?
Well, by breaking things down to modules, it potentially lowers barriers. Learners can personalize their pace and pathway. You could, in theory, tailor your learning journey much more precisely.
That sounds powerful, more accessible.
Potentially, yes. And there's this vision, too, that entire innovation ecosystems should mirror modular brainpage classrooms.
So how companies or research groups work together?
Yeah. They should be autonomous, collaborative, mastery-driven, and deeply structured, like those miniature schools, but scaled up.
And finally, this changes how we measure success, right?
Absolutely. A really profound shift. Moving away from just grades and outputs.
Towards things like brain page quality, modular performance, and the structural understanding of knowledge systems.
Exactly. It's about how well you've built the knowledge structure in your head and how well you can use it, not just what facts you memorized.
So there you have it. The structure phase in Taxshila Technology, it's clearly much more than just a step in building software,
Oh, definitely. It's framed as a transformative learning environment.
where innovation gets internalized, mastered, and transferred. It's really about constructing knowledge architecture, about shaping human cognition, and even fostering decentralized innovation.
Well put.
So as you listen, think about what this could mean for your life, your work. What if the future really does depend on how we structure knowledge, design modular systems, and cultivate mastery, not just in technology, but everywhere, in learners, creators,
That's a
leaders?
powerful thought.
Maybe consider how could you use some of these ideas, these modular principles, these mastery loops, in how you learn something new, or tackle a complex project, or even just approach solving problems day to day.
Mhm.
It feels like more than just a framework. It's almost a call to action, isn't it? That line from the source.
Join the movement, build the structure, master the system, shape the future.
Exactly. Something to really think about.